Swayam Prabha. Digital India. Educated India.
Welcome you all to the next class on Inorganic Chemistry of Life, Principles and Perspectives. In the previous class, we have been looking at several therapeutic approaches, particularly those based on, let us say, anti-cancer. For example, we have looked at the details of apoptosis. We also have looked at the microscopy pictures, confocal microscopy pictures, etc., when the drug is loaded and when the cells die, all these kinds of things we have looked at. Followed by that, we also looked at the photodynamic therapy, where you have a molecule which is nothing but a photosensitizer, and the photosensitizer leading to the activation of the oxygen to singlet oxygen, other hydroxy based radicals, oxo based radicals or reactive oxygen based radicals, which in turn chews away the tissue. So, this is all we have looked at, and let us in this class let us look at some more items of this photodynamic we have looked at, then MRI also we have looked at, MRI contrasting agents, etc. Now, let us look at some kind of a implant kind of things. See, for example, everyone I am sure knows that the titanium is used as implants everywhere in the body, from toe to head, everywhere. So, this is used for the bones, we know very well. It is also used for the hearing aids. It is used in the eye implants. It is used in the, of course, spinal. It is used in the kind of a joints, knee joints, etc., neurosurgery. So, almost every aspect, every facet of human life, there is a role of implants, and even the pacemakers. So, pacemakers which are used to support the heartbeats in this. Okay, here is a slide where it shows a lot of examples of this. For example, the one which you are seeing here is the prosthetic leg, where they use the titanium rods to put into this, and here is a knee joints, and knee joint can be replaced by these titanium material things. So, one can do knee replacement. This has become a most common thing today among a large number of patients in various countries. It is nothing to do with one particular country or the other. Hearing aids are these, and the pacemakers, and also intramedullary rod in bone. So, everywhere the titanium based materials, titanium rods, titanium shaped cups, all these things are put into the human organ implant system. So, therefore, this is quite well acceptable by the tissue, and so therefore, that has been used. Now, let us look at another example where inorganic compounds, inorganic metals, inorganic items play a great or important role. So, when coming to the dental treatment, we know very well people use the wires to control the growth, to control the protrusion of their teeth. And you know that kind of thing. So, these wires, people use caps for these for the teeth. So, these are also made of the metal. So, the metals like titanium, they are mostly of alloys, cobalt, chromium, nickel alloys in different combinations. These are used mainly for making the orthodontic wires. They are also used in making a large number of caps, etc. Cap part will come in a while, and so you can also use fillers cavity as the fillers in the cavity. In the dental cavities are filled with metal melt like gold, silver or amalgam kind of things. These things can be used. Okay, so use to protect these ones, you have caps. The caps can be made of the porcelain. So, porcelain is nothing but a clay material. Kaolinite, this is nothing but Al2Si2 O5 OH4. So, these are all called composites. So, these are all composites. So, the variety of composite materials are used in the dental part either for filling or as a caps. In fact, you can treat these things and then make into a cap by shaping. You can also use the resin crowns. So, acrylic polymer resins, example polymethyl methacrylate. So, these kind of things are also used for making the caps. There are ceramic kind of types are also there, feldspar, sodium aluminum silicate, which is strengthened by the alumina. So, these kind of things are also used. So, opacifiers, small quantities of oxides of zirconium, oxides of tin and titanium, all these things are also used. As you can see, a variety of these things are shown over there. Okay, so, therefore, here you have the resin kind of a thing, here you have a porcelain kind of a caps, you have a ceramic kind of a caps. So, all these kinds, the metal based crowns, caps, etc. So, there are different kinds of crowns and caps are being used in the inorganic chemistry, in the inorganic materials into the dentistry aspect of it. Okay. So, also there are many other things that is done even for the dental part. The other part, what is the other part important? The other important part is the root canal treatment. Okay. So, root canal treatment, once it is done, this requires to be protected. So, how do one protect? They protect by various materials. For example, gutta percha. So, is a cone material used for the root canal treatment. What is gutta percha? Gutta percha is a rigid latex product, is basically a polyterpene material which is obtained from sap of Pelaquium gutta, and the structure can be seen over here on the top in the slide. As you can see, this whole thing is nothing but you have a terpene material you have. Okay, you also have other kinds of molecules that you are using. So, the eugenol essential oil from cloves. So, the allyl chain, you can see the allyl chain in these ones. The allyl chains are basically the ones which gives the oil kind of a property. So, you can use zinc oxide with eugenol based. Zinc oxide with eugenol based is the eugenol is the essential oil which is obtained from the clove, as you can see this one. So, this has got a allyl chain which is a substituted guaisol. So, use these things, or gutta percha or eugenol, zinc oxide with eugenol, all these things can be used for filling the root canals. Also, you can see calcium hydroxide based dental sealers. So, you can seal these one by using the calcium hydroxide material, as you can see that. So, that means inorganic materials are used in multiple ways in dental treatment, as a caps, as a fillers, as a root canal treatment, all kinds of things. Also used nowadays, a lot of dental surgeries are going through, or dental treatments are going through mainly as the implants. In the implant you need screws, and these screws are made up of the tin, titanium and other metals. So, therefore, again one can use in the dental implants too. So, several inorganic materials like calcium phosphate cement, a cement with a calcium phosphate, a silicones, a metal trioxide aggregates like Bi2O3, Al2O3, which are combined with calcium oxide, silicon dioxide, magnesium oxide, etc. All of these or used as dental sealers in root canal treatment. So, almost everything is inorganic. You cannot use organic materials for any filler or for getting the strength, because they do degrade very easily at the body conditions, at the physiological conditions, at the human physiology. So, therefore, it is always preferred the inorganic kind of materials whose solubility is much lower and their deteriorations are also much lower. In fact, most of these caps will stay unaltered 10 to 20 years or so. So, that is the kind of a strength that is provided by the inorganic materials. So, inorganic materials in filling, inorganic materials in the implants, inorganic materials in fitting the body, bones, in pacemakers, in eye contact, even in ear for hearing aid, etc. So, these are some of the things that I have been talking in the last couple of classes about the inorganic chemistry in therapy, inorganic chemistry in medicines, etc. So, let us try to look at the whole thing what I talked in the last couple of lectures or so. So, let us take you back to the where we started with the inorganic compounds in medicine, look at as like a concluding kind of a remarks. I have shown you there are at least 30, 40, 50 different elements whose salts, ions as well as the complexes are used as a medicine. A few of them I would like to remind you by giving you this particular slide, which I have given earlier when I was giving the main lecture for this. So, this is just will help you just to recap the things. For example, silver and arsenic, they are like antibacterial and antimicrobial. Arsenic, that is where the arsenic salts are used for the spraying even in the agriculture, where the microbial killing is required. Gold is used very famously in anti-arthritis. Is basically gold thiolate complexes, gold malate complexes, etc., etc. Vanadium, chromium can be used for anti-diabetic aspects of it. Only thing is that they are not basically in the market, but they have been shown to some extent. In this cobalt as the vitamin B12 supplement, and for example, mercury iodide can be used as antiseptic, magnesium as an antiacid, of course, also can be used in magnesium salts as a laxative, etc. Platinum, ruthenium, titanium, anti-cancer, of which we know very well platinum compounds are being very well demonstrated, very well accepted, they are already in the market, whereas the ruthenium and titanium have not hit the market yet. And so, therefore, but they are reasonably well shown for their activity. Zinc is will have effect even antiviral and wound healing, many kinds of aspects people use. And tungsten is anti-HIV, and gadolinium as the MRI contrast agent, because when you are taking an MRI, you need a contrast between the healthy part of the tissue versus the tissue which is affected by that. Okay, so while teaching you that, I have also given a compilation of the inorganic most commonly found inorganic compounds in medicine. So, you can see aluminum as hydroxide, silicate is antacid, antidiarrheal, antimony gluconate can be used anti-leishmaniasis, bismuth, this is the tripotassium dichromate can be used as antacid, anti-ulcer, boron or boric as in the form of boric acid can be used as antifungal, cobalt in the form of vitamin B12 can be used as for the anemia, pernicious anemia. Iron with glycine sulfate can also be used for iron deficiency or anemia. Gold thiomalate can be used for the anti-arthritis. These are all quite available ones. Magnesium sulfate, magnesium hydroxide, laxative, antacid, and platinum dichlorodiamine is basically used as a anti-neoplastic or anti-cancer. Selenium sulfate as anti-dandruff, silver sulfadiazine is antibacterial, Tin fluoride is of course used for the dental, for the anticaries. Zinc sulfate can be used as a nutrition for zinc as well as wound healing. So, these are all actually available ones through the medicines people are taking. Okay. And the previous slide shows the potential for all of these. So, these are all so if you look at all of these, there is a lot of role of inorganic compounds and in the medicine. So, here I have brought another aspect. Of course, I have shown a lot of compounds in the regular lecture, that lot of the platinum based compounds as anti-cancer agents. Also, I have shown ruthenium based etc. And also I have explained how a platinum based compound will act on the tumor cells. There are two things here. One is the cis geometry containing platin, other is trans geometry kind of platin, cisplatin, transplatin. See, the composition of these is exactly the same, while the cisplatin acts on the tumor cells, transplatin does not act. And this also I have brought to your notice. Let me again bring a recapitulation of this. Both binds, cisplatin binds to DNA, transplatin binds to DNA. Cisplatin binds like a kind of intrastrand, and transplatin binds between the interstrand, where always such kind of things can be repaired by the enzymes in the body, and cisplatin based complexes are not repairable, whereas the transplatin based DNA complexes, those kind of things are repairable by system. Therefore, cis products, cisplatin acts as anti-cancer, and transplatin does not act as an anti-cancer, does not have any use as a drug at all. What is the mechanism? We have seen that the cisplatin entering in and the hydrolysis of one by one halides and replacement with water, and the water is knocked out by the nitrogen or N7 of the guanine residues and will bind to the neighbor guanine residues, and that is how it takes the thing into this. We have looked at all of these. Now, in the previous class and partly in this class, I have introduced to you the therapeutic aspects, where the inorganic compounds, inorganic molecules, inorganic drugs do play important role. Let us look at the concluding remarks of this. To start with, I have explained you apoptosis, I have explained you chemotherapy, I have explained you anti-cancer agents, I have also explained you photodynamic therapy and photosensitizers. I have explained you magnetic resonance imaging and how this is obtained better by using MRI contrast enhancing agents, and also just a while ago I have talked to you inorganic in dentistry. Just to bring a recapitulation back to you, the cells can go through a programmed cell death, where certain other cells have to take the death, and that is a programmed one and the best process. The other one is forcible and unforeseen situations, that is called necrosis. So, apoptosis and necrosis. So, the normal cell programmed cell death, it will give the formation of blebbling, and then finally breaking into the pieces, where the protein is made into pieces, DNA is made into pieces. All this comes by the signals that are given by different proteins, and these pieces are basically engulfed, and therefore no kind of the inflammation or any kind of a problems will be created. So, it is a safe way of killing the cell. The other side, you have a necrosis. In the necrosis it happens by the cell getting assaulted by cell injury, some kind of external pressure. It could be a chemical kind of an attack, it could be a biochemical kind of an approach, or physical kind of thing. So, physical, chemical, biological kind of a signal effects can influence the cell for the death, and such kind of cases that you have the pieces that comes out are not organized, not being engulfed. Therefore, this can lead to inflammation. So, this is a kind of a problem have. And such kind of a the apoptotic conditions can be checked by using cells of the normal type as control, cells of the cancer types as the regular ones, and then study their entry of the drug as compared to the control, study the control the drug placement in the nucleus by using some kind of a markers, etc. So, those things can be identified. So, by microscopy, fluorescence microscopy and confocal microscopy, all of these. Also I have explained to you was the photodynamic therapy. In the photodynamic therapy, initially people have thought it is only the porphyrins which can show the photodynamic therapy because of their extended conjugation, but now we have hundreds of compounds where you have ligands which are quite heavily conjugated in itself, and there are metal complexes, and they have some nitrogen ligands which binds to the metal center, its complexes. So, in the form of such kind of complexes also can be useful for the photodynamic therapy. So, the principle is that the compound will act as a photosensitizer, and the photosensitizer in its ground electronic state with the ground vibrational state, when you incident with light, and this species will get excited to the excited electronic state, probably even excited vibrational state in the excited electronic state too. And as we know very well, there are different processes by which the energy changes can happen from a excited vibrational level to the ground vibrational level of the excited state can happen by internal conversion, and then the species can lose its energy in the form of light by returning to the ground level by giving the fluorescence emission too. Or it can also go through inter-system crossing, where the singlet excited state will turn into a triplet excited state, and the actual emission occurs from the triplet excited state. If the emission occurs from the triplet excited state, it is known as phosphorescence, as we know very well, and if the emission occurs from the singlet excited state, it is known as the fluorescence. Okay. So, now you have an excited species in the triplet state coming to the ground state. This particular energy release can activate the some biomolecules in presence of oxygen to give reactive oxygen species, or it can even activate the oxygen to give singlet oxygen. So, you will have singlet oxygen, you will have superoxide, you will have a hydroxide, you will have peroxide, all these kinds of species. And so, these species that is generated, they are good enough to kill the cancer cell. So, therefore, you are basically using bullets, using a gun. So, this is basically a gun and throwing out the bullets at in different directions and with different speeds and different activities. So, killing all the the cancer cells in that. Okay, having studied a couple of lectures on this inorganic chemistry, inorganic complexes in drugs, inorganic complexes in therapy, I have also introduced to you in the beginning that one can plan to design an inorganic drug either for a therapy or for a diagnosis, or even for some kind of a coating, or even for some kind of a protection. So, all of these, because the inorganic compounds are very much robust in many contexts, and they are very widespread. Why? Why are these inorganic complexes, inorganic molecules, inorganic compounds are widespread? It is very well known. In the inorganic complexes or inorganic compounds, the metal ion can have variety of oxidation states. When it comes to the ligands, and these oxidation redox states can be achieved by varying conditions. Also, these at different oxidation states, the metal ion will have different kind of a reactivity. When they combine with the ligands, they show different kind of a stability, and they can also show different kind of a lability depending upon their oxidation state and surrounding. Coming to the ligands, the metals can bind to 1 to 1, 1 to 2, 1 to 3, 1 to 4, 1 to 5, 1 to 6, 1 to 7. Most of the transition metal ions are generally with 6 and 7. Of course, lanthanide ions will go much higher, and when they bind, they can bind from a monodentate, they can bind from a bidentate, they can bind from a polydentate, they can bind from a cyclic molecule. So, therefore, going from monodentate to bidentate to tridentate to hexadentate to a cyclic molecule, you are increasing the stability by either by the chelation effect or by the macrocyclic effect. So, therefore, there is a variety of space in which you can generate the inorganic compounds, inorganic complexes. You can also have inorganic salts also can be made. Then you can also have different kind of ligands at the same time binding to the metal center, or in the same ligand multiple binding sites. One may be nitrogen, another may be sulfur, one may be nitrogen, other may be oxygen, all these kinds, one may be oxygen, other may be sulfur. So, variety of these kinds of things are also possible. So, that is what I am been referring to, the inorganic chemistry based on the metal ion, the complexes, inorganic salts, some oxides, some other kinds of compounds, they are plethora. They are in fact much more than the organic chemistry combination. Generally people think organic molecule you take, start derivatizing, you can generate hell of a number of molecules. It is nothing wrong in that, in fact correct. But if you take the inorganic case, it is not one element. All elements in the periodic table belong to the inorganic chemistry excepting your carbon. And now a chemistry has been developed with the alkaline earth ions, chemistry has been developed with the transition metal ions, chemistry has been developed with the main group elements. Therefore, all that one need is a smart guy picking up a problem of making the complex. So, you can make with 2 coordination, 3 coordination, 4 coordination, 5 coordination, 6 coordination, etc. So, this will give. So, all of these just by using the coordination chemistry principles, and these will have different kind of interaction with the biological molecules, and they may be in variety of ways interact with the biomolecules to cells to tissues to organs, you can take it. So, therefore, it is possible to bring the inorganic chemistry into the realm of the drugs vis-a-vis to organic chemistry, where we know a lot of drugs are already known. And I am sure with these couple of lectures, I am sure I am able to convince you that there is a huge amount of inorganic chemistry which can play a role in inorganic drugs, in therapy, and in the prosthetic organ making, and many other device makings also, etc. I hope I have been able to convince you with the inorganic aspects in the life of these things. Thank you very much.